Hey everyone, in this video we're going to be talking about drag force. So we're going to have an object, mass m, initial velocity v0. It's going to start at the origin. Drag force is going to be acting in the opposite. So our object is going to be traveling on a horizontal plane. It's not going to go up and down or anything, or left and right. It's just going to be going horizontally, x direction. And if it's going one way, the drag will always act in the opposite way, okay? So it's going to be going with an initial v0. So you kick a ball, it's going to go until some either like air resistance or a drag force, any type of drag force will stop it. We start with our favorite good old F equals ma. We know that we could rewrite a as dv by dt, which can be expressed as dv by dx, dx by dt. We know that dx by dt is just v, is the velocity, right? So it's pretty simple. I mean, after you reach this part, it's quite easy to see what's going to happen. Since we have a dv over dx, that means we're going to have to integrate. I forgot to say, we want to reach a point, well, to express the position of the object as a function of its initial velocity, which is why we did this. Okay, otherwise it would be a whole different process. Well, not like too much different, but so now that we have the dv over dx, we know that we could work this out to have a function of the velocity. X is a function of v. Anyway, now, and another important thing is, since the only force acting on this object, it's already been kicked. It's already going. It has a v0. Only force that's acting on it now is this drag force. Okay, so it's sufficient enough to equate these two. That's exactly what we're going to do. mv dv by dx equals negative cv to the 3 over 2. Separating the variables, so dx on one side, cv, like this entire term, on this side with the dv. So it's going to be dx equals mv over negative cv to the 3 over 2 dv, which equals m over negative c times v to the negative half dv. So you could kind of ignore this middle part. I mean, it's all equal, but the two little v's will end up forming this v to the negative half, which is 1 over v square rooted. So at this point, we're just going to integrate so we're going to integrate the dx with respect to, obviously, x, but we're going to integrate from 0. Since we start at the origin, we're going to go up to x. On the v side, we're going to go from v0 to v. So we could just put it here, really. 0x v0 vf. And the reason we can take this out, the m over negative c, because it's constant. So m is in kilos, c is just going to be a constant, some random number. Okay? So we get x of something equals m over negative c times 2. After you integrate it, it's a pretty easy integral. Should be able to get that. V to the negative half, evaluated from vf to v0, which is going to equal m over negative c times 2. I don't know why I'm writing it like this, honestly. Just got this board. M times 2, and then we have v square root of vf minus square root of v0. Now, an important part of this whole, problem is to understand that when this object is moving, it's eventually going to stop, right? So the vf is consequently going to be 0, which is going to make our lives a bit easier here. Actually, a lot easier. So, and then another important thing is you have the two negatives here. from the integral evaluation, and then from the negative c from the constant of the drag force. And then since, a little spoiler alert, since we already know that the VF is gone, this function is only going to be a function of the V0. So this is going to be V0. I'll just rewrite it here. X of V0 equals 2m over negative c square root of V0. And there you have it. So this is the position as a function of the initial velocity V0. So you put in an initial velocity and you get the position. This is positive, I'm sorry. I'm just going to remove that. Totally. There. 2m over c, yeah. Okay, if this helped you in any way, please leave a like. If you like the video just in general, please leave a like. If you want to see more, you can subscribe, that'd be great. It'll help me a lot. Just kind of in the beginning of this process. So if you have any advice or suggestions, please let me know. But yeah, other than that, I hope you enjoy your day, and yeah, see you next video, I hope. Bye.